So I'm wondering, maybe we have some new people. So I'll just.
Drew, do
Yep.
you send? Is it possible to send through the RISC-V platform like email invitations for the scheduled open hours?
To where?
To everyone that's in the mailing list, like send the invites for the calendar invites, or have that published as a calendar. Do you have
Publish it
that?
as a calendar? Well, it should be on the let's see here if I
on the RISC-V calendar schedule.
Let me go here. Yeah, let me click on the calendar. I think it's on the calendar. If not, I can ask Megan to add it.
Maybe I'm not.
No,
I'm not
actually, you're right.
that.
It's not on the technical meetings calendar.
Mm-hmm.
Okay,
Yeah.
so yeah,
it would be nice to have something like that for like a reminder, like 15 minutes before every open hour meeting. Yeah.
Yeah, I think if you RSVP for it, I believe if you had gone to the event page and RSVP'd, it just send an email to you. I don't know, maybe like a day before or something like that. And then I usually there's basically no traffic on this mailing list, but I do usually right before it starts, or at some point before it starts, I usually try and email out to the mailing list, though there aren't that many people on the mailing list. So I don't know how many people actually see that, but I should get Megan to add it to the technical meetings calendar.
Cool.
Yeah, so if anyone's new, the idea here is just kind of informal hangout, and if anyone ever has anything they want to present, happy to hand over the screen and you can share. It doesn't have to be anything formal. It could just be like sharing a window on your desktop. You don't have to have slides or anything like that. And yeah, as I was saying there, we do have a mailing list which you can join if you want to get notified. Though it is also on the community.risc-v.org website, which is probably how most of you got here today. And if you click on the link there, you'll see all of them listed, which actually brings up the question of where does the chat go? I was going to paste this link in. So that'll take you to all the open hours. But then, as it turns out, there is a Yocto conference next week that I'll be attending that conflicts. So next Wednesday evening in the US / Thursday morning in Asia would be the next one. So if it's someone else wants to host it, then I can give the info. Otherwise, we'll probably cancel that one. And then unfortunately, I will actually be, I'm going to my company's office in France middle of December. So I won't be able to do the one on the 15th. So yeah, if anyone's interested in hosting either of those, let me know. You know, the more important one is probably next week. So I don't know, Fue, would you be around for next week?
Yes, the same time, right?
Yeah, no, this one would be the one that's actually for Asia. So this would be the Wednesday. Sorry, for you it'd be I guess December 2nd, Thursday morning.
I guess we. Let me see. I guess we will have one next week. I in my calendar is next week the same time. So
oh, okay. I think it got messed up at some point. But the one next week, it should be the Asia one, since we try and alternate between
okay,
Asia.
yeah.
This is the one where it's the evening for me, so it's the morning for you.
I'm not sure, but I just check it in my calendar. The next one is the same time. It's not in the Wednesday. It's in the Thursday midnight.
I think
it's Thursday very early morning at the same time, 1 a.m. for me. So is that you? And then the next, let me see.
I think there might have been a mistake initially on this one, but the current what should currently be in there is that this is the one that's going to be on Thursday morning in Asia. So yeah, if you're up for that, or maybe Weiwu would host that one.
I definitely will be there, and I'm not sure if we wanted to host that or not. Just yeah. If he want to do this, let him do it. If he he is okay, I can try. Yeah, no worry.
Okay, I'll email you guys and let you know. And then the other one is, unfortunately, I'm going to be traveling on the 15th. So this would be the next one that would be for Europe. So if anyone's interested in hosting the one that would be on the 15th, so this would be the evening in Europe on the 15th. Let me know. But that one's 2 weeks from now, so we don't have to decide that right now. And then otherwise, things should be normal once we get into January. Yeah, and if anyone's not seen it, there's still the developer board giveaway program. So if you want to work on a project and you need a RISC-V board, I recommend filling out the form. It's mostly the all-winner D1 NESA board that's available through this. There are some other ones. And then finally, the RISC-V Summit, which Carl was mentioning, is coming up in just 2 weeks, I guess. So the week after next week will be the RISC-V Summit. So I'll be there for Monday and Tuesday. I guess Carl will be there as well. And I think Akira is coming from Japan. So that should be cool. But I was looking at the schedule, and there's a lot of, I think, talks from people that aren't going to be there as well. So hopefully the virtual will work pretty well. Let's see what else I had. Oh yeah, and just for people that, I mean, I think most of you are, but if you're not familiar, there's a mailing list server that has where a lot of the communications happen for all the different technical groups. And then there's, as I was shown earlier, was the technical meetings calendar, which is how I find out about most of the meetings. And I'll get our open hours added to it. I didn't realize it wasn't in there. And I didn't want to highlight tomorrow morning for me here in the US. I guess it would be, I don't know, when would that be? Fue? I guess it would be your evening on.
Which one?
Anyways, well, I was trying to say that the software horizontal committee meeting is coming up tomorrow. So that's like the monthly one that Philip hosts, which is usually a good one to attend. The software horizontal committee. So that's coming up tomorrow. So that's when I usually try and attend, because they kind of go over all the different software groups. I was just saying it's 9 a.m. here in America on the West Coast. So I guess it would be Thursday evening for people in Europe. And then would it be, I don't know. I'm confused when that would be in China. I guess it would be Friday evening for you.
Yeah, it's the same time.
Okay,
It's the
yeah,
same
same
time.
time. Yeah, so it'll be a bit, you're right. So the same time tomorrow, 24
Yes.
hours now, the same time is the software committee meeting, which is like the
Hey, Drew,
umbrella one.
we can only see your slides. We can't actually see the thing that you're showing us.
Oh, okay. Maybe I shared only.
And they're still going to meet tomorrow, despite it being the holiday here in the US?
Yeah, I didn't see an email yet. So I think it is. Can you see the calendar now? Or is it?
Yes, thank you.
Okay.
Yes. Yeah. So yes, for people that don't know, tomorrow, the 25th is Thursday, is Thanksgiving here in the US, which is a national holiday. So, but it's hosted by Philip, who's in Europe. So I'm not 100% sure. And I haven't seen an email yet about it, but it may get canceled. But I haven't seen an email about it yet. But this one I try and attend because it's once a month. And it's kind of usually like a recap of what's going on in the different working groups. But I do agree. I think if any of the attendees from the America probably wouldn't be joining, but in general, it's a good one to look out for, since it kind of recaps all the other things. If you aren't able to get to them, and then the other one that I try and get to is the platform spec meeting, which will be coming up on the 29th. And HSC stands for Horizontal Steering Committee, which is basically, it's just the meeting where they talk about the platform spec. Yeah, let's see. And yeah, I skipped a lot of these slides since we'd already kind of talked about them before. I don't know if I'd mentioned in this one before, but over the last couple of weeks, Linux Foundation finally posted all the videos for the Embedded Linux Conference and Open Source Summit in Seattle that happened back in September. So there's like 5 different RISC-V talks. So I linked to all of them there if you want to check them out. And let's see what else. Yeah, if people aren't aware, there's an Android special interest group, which we've had good discussion about in the version of open hours that happens in the morning in Asia. Like last time, several of the people from Alibaba had joined, which was nice. And if you hadn't seen it, there was a presentation somewhat recently and a blog post on riscvi.org about how Alibaba T had ported Android to RISC-V. And I'm not sure, I mean, this might be new since we met last in the European time zone, but Alibaba now has all their cores are open source, which is pretty neat. And then someone put together this little DIY board. So apparently if you have access to Taobao in China, you can get some of these chips now. So both like the Allwinner D1 and then this F133, which is the D1 with integrated 64 megabytes of DRAM. So someone designed their own DIY board in KiCad, which was pretty cool. And then a pretty similar, and I don't think this person, I communicated with them, they're a student. I don't think they're probably interested in really like making this and selling this, but if you want to build your own and you have access to Taobao, it seems like a interesting thing you could do. Mango Pi is kind of a similar one. It's that same D1 with 64 megabytes in package on a small board. And I know they are, I think, getting ready to start selling them. Also, I thought it was neat that it was designed in KiCad. And then I saw this recently, maybe this week, that the SciPede has this board coming out with the discrete D1 and what is it, 512 megabytes. So that looks pretty nice. So that looks like a pretty nice little board and a lot cheaper than the Neza. So I think that would be a pretty good one. Oh, Daniel, you just said that you ordered one. Cool. Do you know when it said it's going to ship, Daniel?
No, unfortunately not. I'm sorry.
Yeah,
Oh,
so
I also ordered 2 of them, so I got a shipping estimate of early January.
Okay.
So let's hope, including transfer to Norway, so that might take some time in itself. Let's hope for the best. Yeah.
Cool. Nice. I wonder, what is this form factor here? Do you know what the bottom, the edge connector is?
It looks like 2 PCIe connector things, but that might just be coincidence. So
yeah,
it is. So they're intending to also release another board where you can plug this in, and there is also going to be another variant which actually has a header. So yeah, this is more like, if you know the Raspberry Pi compute module, it's essentially the same idea. So there's going to be breakout boards probably where you can, just put in multiple of those here.
okay. Yeah, I think it was actually in the Telegram. I think one of you posted it. So it's this picture here, right? The carrier board.
Yeah, exactly.
Okay.
Yep.
Neat.
That's not the carrier board. That's the full SBC with the header. The carrier board isn't yet on Twitter as far as I've seen.
Okay, so this is a different. This is just a different version.
Yep. So this is a fully fledged board. You can also see it's got the HDMI connector on the left.
Okay. Cool.
Yep.
So these are PCIe connectors then?
Looks like M2 connectors, yeah.
Oh, M2. Okay.
Yeah, looks
Yeah,
like 2
I think those
M2
are E
side by
key and
side.
GFF.
Yeah.
Nice. Yeah, so that looks pretty cool. And then I guess, did anyone order the C910 board? I think I mean that was a little while ago now, but I don't know if they've shipped yet or not. But this was with the bigger one, the C910. Do you have one of these?
Yeah, so Bruce
Who?
from the Telegram ordered one of
Okay.
those, and
Cool.
I think he's about to receive it at some point soon.
Estimated delivery on in time for Christmas.
Yeah, I think it's already shipped, and he
Okay.
just needs to hunt it somewhere in Australia now.
Okay. That's neat. So I guess this is the one with 2 C910 cores, I think. Yep. Oh, wait, did you have, I know you'd been working on the D1 support. Do you have,
Yes.
is there any updates on the page that I should pull up or?
Yeah, actually some quite good update for D1 development. I have rebased all the patch from Samuel, and I have successfully add Fedora configure on that, and it's adapt and SD card, USB, and Ethernet works. And I also try to connect with Ovina and Samuel and see if they can cooperate together on some duplicate driver. So they have a same CCU driver, and some of the driver has been upstream by Samuel. So I'm trying to convince. I'm already let Ovina engineer try to working on the upstream one, so they will give up their own driver and try to working on upstream. So I try to make these two parties to work together, and I already update my repo, and people can try to recompile that, and we already made a new image for D1 which can boot from Grub. That's the first one we can boot from Grub, because if you are using the old kernel from Ovina, that's 5.4.61, which is cannot really boot from Grub, which doesn't have stop kernel stop EFI stop support. So we're already trying to working on upstream. The upstream support is accelerated. So I think that's quite a good news. So for now, one of my friend is working on RPN package D1 kernel, and after that we will try to merge Vision File and D1 kernel together, and we're trying to use one single kernel to boot different board. So after that, if we can support the other board, like Unmatched or something, we're slowly to merge all the kernel together and trying to using a unified kernel. I think that's all the update, and we are making new imaging. Yeah.
Nice.
If kernel if I rebase every week successfully, we will try to update D1 imaging every week for now. Yes. And for now, I'm trying to solve RTC problem, because right now the RTC driver is the date driver, and it's a fake driver. It's not really driver. It's just trying to make system boot. But right now, when I'm trying to see if we can make this work, and also trying to fix the problem for Wi-Fi, because I think Weiwu's team already made this work. I'm trying to get some help from them and see if I can make latest kernel working on Wi-Fi chip. So yeah, that's all from me.
Which Wi-Fi does it have on it?
I kind of little bit forget. I got this info from someone. Yes.
So does it need it has to, like, does the driver load firmware then into the Wi-Fi module when it boots?
Yes.
Okay.
Yes. It seems we just need to fix the firmware problem. What I heard from Weiwu's team. So
So is the link, the pre-built image, is this what people can download? Is that the latest?
Yes, we do
Okay.
have that. I will update my wiki page as soon as possible
Okay.
because for now we have two things. One, you can put the original kernel from Ovina, which has a graphic support, everything. It thinks everything works, but it's a date kernel. You can also put into the grub, let it automatically put into the latest kernel, which can, we can try to working on an upstream kernel. So I will update this as soon as possible. Yeah.
So you're on 5.16 already?
Yeah,
Or-
5.16
okay.
RC2 for now. And
Okay.
recently I also update the OpenSBI and Uboot for D1. So everything will be there. Yes, if you check if you are tracking my branch, you can see, yes, this branch works. This branch
Okay.
is the latest one and it also works.
Okay, cool. Nice. So this is already what, RC2. Wow. Okay. Very,
Yes.
very
I
fresh.
will definitely try and put some work in to see if I can make this work on the Unmatched board here in the next couple of weeks.
Cool. Okay. So what kind of a packet, how to say, which patch we need, or how we can recompile Uboot or something? That's what I need, because I have a Unmatched here. I just don't have too much time because I working on several different boards. So yeah.
Totally understand.
If you're interested on some other board, let me know. I'm trying to merge everything together.
I've actually got my Unmatched in a pretty good state with a bunch of upstream code at this point, so it should be relatively easy. The hardest part for me has been the kernel, but I think since you're running on a new enough kernel, it should have the bits and pieces on it. So I'll see what I can do. But yeah, like Fedora was going to be my next stop, and then I'm hoping that I can try and get Debian after that. So I will, like I said, I'll start looking at your stuff this weekend and see if I can put something together and go from there.
Thank you. Yeah, if you know how to recompile OpenSBI and Uboot on that, any patch we need, or maybe we don't need any patches, maybe upstream things, please let me know, and I will try to make a wiki page there.
I think the last time I built Uboot, it was off of your branch, so I think you have all the patches you need. It might just be a couple config options that need to be turned on. So we'll figure it out.
Yeah, thank you.
I have in my GitHub, I can post a link here, like a guide on how to build everything from scratch, like everything, Uboot and OpenSBI and the kernel and everything using Sci5 patches. It works pretty fine. It's not updated to the latest versions. I have to take a look on what David has been posting to the Sci5 patches and stuff, because it's all based on that crazy, I don't remember the name of the structure they built stuff, but I extracted the patches and have written a guide. Yeah, that's over there. It's an Unmatched. Yeah, if you look in the Unmatched folder. Yeah. Over there. Yeah. And I have over there a guide with everything you need to build it all from scratch. It's what I use on my Unmatched board. It pretty much works. I just have to take a look and update that to the latest kernel, Uboot, and everything else versions. That's been a while, a couple of weeks or months that I don't take a look at it. But
I will contribute patches to you because I've got Grub working as well using UEFI.
Oh, cool.
So
cool.
We're getting close.
Well, so you have a UEFI working on Unmatched?
Yeah, with just using Uboot, and that's loading the Grub RISC-V build. I actually got the instructions on how to do the Grub stuff from some other wiki page on Fedora, so I'll put all that together. But the trick is, like, I can get that part up, but then at the moment, any kernel I try to boot that isn't the one that comes from the BSP that ships with the open embedded image that ships with the Unmatched, it gets halfway through and then just kind of falls apart. So, and at this point, the number of patches that are integrated from Sci-Fi is like for changing the LED color, and I don't think we all care. So like it would be nice, but it's not the end of the world. So I'm trying to figure out what's wrong. I think it has something to do with device trees and clocks, but I'm unsure. So that's why I wanted to start like looking at your stuff and see how far I can get. I put a bunch of posts in the Sci-Fi forums, but there hasn't been a lot of response to them, but whatever. I mean, I'm having fun, so it all works out, but I will definitely put in the information of what you need. Building a grub image is not difficult. There's a couple steps that are a little tricky. You basically have to build a grub image that has a bunch of modules already in it. Otherwise, grub comes up and you can't talk to it.
Yeah, but for grub, I just update my repo. It works. It can boot. It just recompile it. It works. So anything. Maybe you can check my repo. I'm using the latest V3 patch set. It add a little bit fix for temporary fix. I just discussion these things on Sci-Fi forum. So I'm not sure.
I just saw those thread updates this morning. I haven't had a chance to read them yet.
Okay. Yeah.
Yeah, that's the link where it comes from. The Sci-Fi used this open embedded that's insanely complex and full of scripts, and I extract everything and build it all from scratch. I just take the patches that we need.
Full of scripts that break all the time. I have spent so much time trying to contribute bug reports going, hey, look, this person left canonical and their stuff isn't on their canonical page anymore, and we got to change it to a oh, it's so painful.
Yeah. I just copy over the required patches to my repo. I just use the patches in my repo that comes from this. I don't even copy them. I only link them to the original ones.
I always use my own SDK, own script. So get every component together.
Yeah, the open embedded build from RISC-V also takes about 10 hours on my Threadripper. So yeah, it's a little intense.
Yeah, I tried not to even create a script. I prefer to put all the comments separately so people that read that understand what they're doing, and you have like transparency on what's being done. Also, I have like a guide to build the root file system for. I built this for Ubuntu, but you can build any root file system you need with that. And put things together, like put this kernel OpenSBI, Uboot thing, and the root file system together. It's how I installed my own Unmatched.
Right. So you're just you're applying the patches from the meta Sci-Fi layer directly.
Yeah.
Exactly. Avoiding bit bake.
Yeah, I tried to understand that, and I gave up in like 3 minutes, and it's terrible. Also, the kernel patches, I have like a full config in this repo, on my own repo, a kernel config that adds like requirements for containers, Docker, Kubernetes, network stuff, and everything that you need mainly for running this kind of stuff. So
nice.
It pretty much works. I run like Kubernetes or K3S or Microshift on my Unmatched normally 100%.
So
nice.
That's why I think we may need to get a Fedora kernel on that as soon as possible. Yeah, and we don't need to work. So for you are working on Kubernetes or some container stuff. You don't have to worry about any configuration. So just use that. Yeah.
Yeah. Exactly. Yeah.
For D1, you can totally just use that. If you find any configuration we are missing, just let me know. I will merge into my repo.
Sure, absolutely. I'll let you know. Like right now, I'm running Red Hat's Open Microshift on Ubuntu, but it's all over the place right now.
Jim just linked to an experimental Fedora image for the Unmatched. Did you see in this, Fue?
No, I trying to make it by my own kernel, and we are making RPM for D1, kernel RPM for D1. So we can make this image in China Koji system. Yeah, so we're just waiting for the how to say. Oh, I'm just waiting for the kernel RPM.
Okay.
Yeah. But if I can have a patch that, we can make it very quick.
Nice.
For kernel, yeah.
Because I'd had a someone had just gotten their Unmatched board and they said, hey, what should I install? And I knew there was the official, you know, Yocto based image, but then I seen Ubuntu has a thing you can download, but I hadn't seen anything for any of the others yet. So I guess this could be something to point people to then. Because I was a little surprised that Ubuntu was the only one that seemed to have an image that you could download currently. Though this is, I guess, this is what, from the 11th? Yeah, so I guess I can point people to this now if they want to try out Fedora.
Yeah, it's a good stuff. And yeah, would you mind to paste this link in the chat?
Well, this one Jim just pasted it in.
Okay, cool.
Yeah.
Yeah, got it. Yeah, I will try to back up it.
I don't actually have a Unmatched, but that looks nice.
You don't?
No, I never,
have
which
it.
is ironic because my partner Helen, she works at Crowd Supply, but sadly we did not get one. I was like, well, there must be one at the office that I can get, but actually with Crowd Supply, it's actually it's fulfilled through Mauser, which is in Texas, so it's nowhere near here. So sadly, I didn't get one.
I guess pretty quick you will have a better one. We can enable PCIe on it also.
Yeah, but I mean, I really like the form factor of the Unmatched. It seems like, well, I think Carlos, he built a little PC.
Yeah, like with a computer case and all.
Yeah.
Like
Yeah,
a very
right.
tiny computer case. Yeah.
And the 16 gigabytes of
micro.
memory, it's like, wow, that's the
Yeah.
same amount of memory I have in my actual computer.
Yeah, my laptop has that. Yeah.
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 That was actually feedback from the kernel developers of how much RAM they wanted for doing kernel compile. So it was nice that they were able to bump that up to that.
Yeah.
Yeah. That's
Exactly. Actually, memory was never a problem with sci-fi stuff, because even the Unleashed had like 8 gigs of memory, and I never had anything.
Yeah. I guess, once because they're both relatively expensive boards, so once you get up into that price category, I think maybe adding a little bit for RAM is not a big deal.
Yeah. I agree.
So you have a NVMe in your Unmatched? I saw from your comment here. Okay, cool.
Yeah, I do. I have the root file system in the NVMe, and only the boot, the Uboot and OpenSBI on the SD card, and they call the root file system. They call the kernel Uboot called the kernel, and init drive from the NVMe. Yeah. So nice. I can usually when I update Uboot or OpenSBI, I flash another SD card and put that one to make sure everything is fine, and then I keep 2 cards to have one working at least.
I'm doing the same thing, and I'm looking forward to the day where I can have the SPI and Uboot stuff on the SPI flash instead of on the SD card. That'll be a lovely day.
That would be perfect. Yeah. And also I have like a I think Jim Wilson is in the call. He probably knows that I have like a engineering sample or something like that board. And my board has a couple of like glitches. And one of the things it has is like it only boots when its console port is connected. Like I have to have the USB connected to the UART on the board to make it boot. Otherwise it doesn't boot. It's something related to hardware. Yeah. And I usually, what I do is I have like a piggyback. I plug the USB UART into the board itself to avoid having like a cable dangling around, and it works nicely. So it's kind of wonky, but works.
Nice.
Also, my RTC chip is a different revision from the production ones. And I just got a kernel patch merged like a couple weeks back to add this new revision of the chip that is different.
Okay.
Dialogue stuff, whatever.
I noticed here it says that some of them have a PMIC that's newer than what's supported upstream.
Yeah. Oh yeah,
Or I
that
guess-
dispatch, exactly dispatch have been merged a couple of weeks ago. Yeah.
Okay.
Upstream on 5.16. Yeah.
Oh, you posted it. Nice.
Yeah. Yeah.
Okay,
It's
cool.
already in the entry. Yeah. It's already upstream.
Nice. So that got into 5.15?
5.16.
5.16.
5.16.
Okay.
Yeah.
Okay,
5.16.
cool.
It will be on 5.16. Yeah.
Nice.
It's pretty much the same as the revision, but the kernel didn't pick it up. So I created
Yeah.
this patch and
This is like the best case of adding support for a new chip when it's just you
Yeah.
have to add the ID, right? And then everything else still works. Yeah.
and
that's
everything is the same.
Yeah.
Yeah, exactly that. And it's pretty satisfying to see your name on Linus kernel
Yeah.
tree.
Yeah. That's great. But I had
Even
not
though
seen
it's
these
like simple
instructions.
patches.
Yeah,
Yeah.
yeah. I had not seen these instructions before, but this looks
Oh,
really
no.
useful. Very nice.
Yeah, I try to keep it like as straightforward as possible, but also very verbose so people understand what's going on and can adjust as needed. This type codes partitions they are hard coded in the chip itself, so they look for these UIDs. And,
Right.
and also the alignment is crazy. Like the second partition, it's one thing that I got beat up so hard, and David helped me. Yeah, it needs to be exactly in this this alignment, otherwise it doesn't boot. Yeah.
So is it the FSBL assumes that it's in these locations then? Is that the constraint?
I think so. Yeah.
Okay.
Yeah. And then
So,
I have sorry,
mhm.
go on.
Oh no, I was
No.
gonna say, so yeah, this looks really nice. I might I can point people to this if they have an unmatched and they
Cool.
want to
Yeah.
build their own system.
I think Jim Wilson posts those instructions all time in sci-fi forums, and I thank him for that. Yeah.
Nice. Yeah, oh, that's
Yeah,
good.
I have an exact same guide for the Unleashed as well. I built that away when I got the Unleashed and started building images and stuff like that. I wrote the exactly same guide. I was starting to write one for the Big 05, but then I got stuck in the middle and the board got canceled, and I stopped doing. I had it like in drafts.
Well, I'm glad. That's good. It's better than I'd feel bad if you had written it. So it's good. It got scheduled out and then it was unnecessary. But yeah, this is great. It's also kind of nice to see how to build it from scratch, so to speak. That's quite nice. And I saw you also have instructions for the rootfs as well. So that was kind of neat with the deb bootstrap and all that.
Yeah, exactly.
Because I do use Yocto/Open Embedded a lot for other projects, but I agree. I mean, I have a server that I run it on, a company server, because it's a lot, yeah. And yeah, I think it's a lot to tell someone that gets a new dev board they need to do a full Yocto build, right? So this is nice. Plus, unless I mean, it took me like 6 months really to get comfortable with Yocto. So it's really one of those things like unless you really need to learn it for like ongoing work, like it's a lot for someone to tackle if they just want to get their dev board to work.
Yeah, it's too complex. Yeah, a lot of stuff because it builds everything like the root file system and the kernel and drivers, and it's crazy. Like I never got my head around it.
Yeah.
It's very complex.
I do like it a little bit better now that I have a server that from work that I use. That's made it a little bit nicer, but yeah, it's definitely I do spend a lot of time waiting for BitBake. So I think this is a very nice alternative. I can see why Sci-Fi wants to use Open Embedded, because I think it makes a lot of sense, but it's one of those things where it also is a pretty high barrier to someone that just wants to, like, they don't do this for their career, but they just want to get their dev board to work, you know.
Yeah. Also, I wrote this in this style because you can do stuff separately. Like I only want to build the new kernel, and you can grab this section on the kernel, build the kernel, drop into the board, and you're done. Or I only want to update Uboot, and you don't need to do everything from scratch every time. Yeah.
Yeah, so very nice.
I need to update that because I think David released like already two new revisions of the Sci-Fi patches. Also probably the newer kernels. I think it's on 5.13 over here, and maybe Sci-Fi patches already work on 5.15. So I need to update that, the guide and everything, and even update my own board because I haven't updated since then.
Okay.
I only keep Ubuntu itself that packages updated.
So one of the things I was wondering about with ext Linux, so I guess is it Uboot that's jumping to ext Linux?
Yeah.
Is that how it's working? Okay.
Yeah. OpenSBI just calls Uboot, and Uboot reads xlinux.conf and reads all menu.
Uboot has Uboot has some code in it where it understands the ext Linux configuration files. It's part of some obscure standard for multiple boot things, but you can also put in the Uboot automatically understands if there is a appropriately labeled EFI boot partition, it will jump to that, find the appropriate executable, and run it as well. And it does that before it goes and does the ext Linux stuff, which is kind of nice.
Okay, cool.
I never understood exactly why, but I got that xlinux.conf came from like a legacy or another system that was integrated afterwards into Uboot, right? It's syslinux or something like that.
They needed something that could give you a configurable bootloader, and the ext Linux stuff was really easy to parse. And like I said, there's some obscure standard for it, but that's what they implemented, and it's not bad. It's just that like no distribution supports it out of the box.
Yeah, you know, I fiddle a lot with power computers, power machines, and I love their petit boot stuff. That's in the end a Linux kernel that loads everything. Like it can read practically anything you have. Grub, it will read it. Anything you have, and it builds like a nice menu, and you can choose like dynamically. It's pretty nice. I like the way it works.
For this ext Linux, actually in Uboot is a configuration called or option called sysboot. You enable sysboot, let sysboot to pass the ext Linux configure file. Before where I'm start to use sysboot, I'm using boot I command to boot the Linux kernel. So once you can use the boot I, and then you can switch to sysboot. And I think at the very beginning we are using boot M to boot the kernel. But yeah, once we finish the configuration for kernel and rootfs or something, figure out how to boot it, the command line for kernel. So we can just use the ext Linux. But for now, I'm using Uboot to execute a grab EFI, and then we can use a grab configure file to boot up the kernel.
Yeah, that works well. I guess when I first saw it, it confused me because it's a thing from syslinux, which was like for like booting CD-ROMs on x86 computers. So I was confused when I first saw that because I was like it didn't seem to fit. So that's good. It makes sense that it's just Uboot that's reading it. So that's good.
But also Uboot have those weird scripts that you can write to make it boot, and it's practically unreadable, like crazy hard to understand everything. And I think xlinux is pretty straightforward to understand. It's the closest to Grub as you can get, being without Grub.
Yeah.
At least in my opinion, yeah. It's very simple. Yeah.
Did anyone want to share their screen? Yeah, if anyone
Yes,
has anything.
I can
Yeah.
give a little intro here to
Sure.
the Orboot project.
Yeah.
So hang on a second. I'm arranging some things.
If I share my
Screen share
screen,
is
you guys have
disabled,
to
it
help
says
me.
here.
Okay, let me see how I can do that. Oh, make you a host. Yeah. Okay, now you're a host.
I gotcha.
If I share my screen, you guys have to promise me to help fix a thing in Scala that I'm fiddling with in adding a PR to chisel.
Okay. So yeah, I don't see my own preview here.
Yeah, we see the
But I hope you can
Orboot
see it.
on GitHub.
Right. All right. Okay. Yeah. So let's start with a little intro because not everyone maybe knows Orboot, but you might know Coreboot, which Orboot is just a fork from, and it's written in Rust. So basically, we just dropped the C, not as the first letter, but also the language. We're striving to really just keep everything in Rust. If necessary, we do a little bit of assembly, but yeah, we try to avoid it. We already have support for multiple architectures, RISC-V being one of them. And so for supporting multiple payloads, we just use the Linux boot project. If you're not familiar with that, it's basically just a Linux kernel that is then using kexec for running just whatever other payload. So I don't know, whatever you want. It can be another Linux, can be Plan 9 or I don't know, XV6, for example.
Similar to Petit Boot on from OpenPower. Yeah, nice.
Yep. Yeah, exactly. And that's actually where Coreboot originally came from, right? So originally it was really just a Linux kernel in the SPI flash that would just run your operating system.
Is there
Anyway,
something
so
that comes before it then? I guess that with Linux boot, is there something that runs before Linux boot then?
yeah, that would be Orboot or Coreboot or whatever.
Okay. Okay.
Yeah. Yep.
All
So
right.
it's basically just a bootloader like grub or something. And so we were just talking about syslinux here. That is supported by uroot in Linux boot. So Linux boot is really just the concept behind it. And what we use by default is an environment called uroot, which is just written in Go. You know, it's all the command line utilities that you know, like, I don't know, cat and so on. And it also contains the bootloaders. And those bootloaders support like all sorts of different formats. We can parse grub, not completely, but the basic configuration file, right? We didn't want the scriptable parts, let's say. And just like that, we support many others. So the idea is really that eventually you can just boot whatever distro you want if you have an image ready to go. So I'm currently porting Orboot to the Inertia board. And where I'm at now is basically I already got the execution part running. I got the serial set up, and I can already hop over to some other payload. So it works with XV6, for example, just right out of the box, where we just stay in machine mode. And that's actually what we prefer. However, the current D1 kernel is not really made for that. So we actually need to transition using some implementation of SBI. But we actually don't really want that. So we want to keep things really, really simple. So we want no UEFI or SBI or something. You know, we really just want to do the bare minimal initialization and then hand over to an operating system, which is in full control of the platform. So here you see my terminal now. This is the structure. So we have a source directory where we have everything ranging from drivers to multiple crates, that's the modules in Rust, to mainboards eventually. And within mainboard, if you know it from Coreboot, it's basically the same structure. It's like, you know, the vendor, the specific board, and within that possibly some variants. But Orboot is still a bit of a young project, so we don't have you know, hundreds of boards. We have more like 10 or something. To give you a very rough structure here, this is my current directory now for the Ninja board. I have a few things lingering around here: a Linux kernel, an XV6 kernel, which is you know, linked at a specific address, and then I have a few scripts. And we're using Makefile. So I can show you this Makefile here. It's really, really simple. all it's doing is really just setting the target and, well, potentially some flags for running in QEMU, but forget about that. It's basically just copy-paste work from some other board. That's not meant to be usable here now. And so for now, because I don't have DRAM in it yet, I use the exfil tool to initialize the DRAM, copy over something, and then execute it. So this something would then either be a boot blob that's really just our code here, which is a few kilobytes if you want, like, I don't know, maybe around 100 it will be. And if I have the full image, that's this thing here, make run is the default target to run a full image. And so I have a little script around that because we support multiple payloads, and that's this here, run.sh. All it's doing is set some environment variables. This here is my own custom one, which is specific now to this board. I guess we may drop this and implement it in a different way. So what I'm currently doing is I'm using a REST-SBI implementation. So REST-SBI is an SBI implementation, which is currently available as a library. So what you would do is you would take that library and implement your version for a specific board. And that's this one here, REST-SBI inertia, which is basically students' work. I took that and another implementation, which was called REST-SBI D1, and then I crammed everything together to have one runnable image. And that really just sets up all the traps that you need and basically then drops you into the supervisor mode and execute the next payload, which is then currently here set up to be the Linux kernel. But it can also be anything else like Z-Core, which is an implementation of the Zircon kernel in Rust. Anyway, long story short, let me just run the run script.
Is that VM Linux? Is that for for Linux boot then? Is that what that VM Linux is there?
Yeah, exactly.
Okay.
Exactly. So yeah, so the current image that I'm using, that is a Linux kernel with a built-in initramfs, which holds a uroot image and something that is called CPUD, which is a daemon you can use very much like SSH, but it does an implicit mount over the 9P protocol that you know from Plan 9. And that way you can run anything on the remote target that you could bring from your machine, right? So you can just use the CPU command and you can execute anything that is in your local machine on the foreign system. And it can also be a different architecture, right? Because it's really just mounting things over. You just bring the binaries yourself you want to run somewhere else. So you just need to build it for that target and then you run it. So this is how far we get. This now just copied over the image, so it took a bit over exfil. Anyway, and that's executed from RAM now. So what we see here is, this here is from the DRAM init, the first part, and then the friendly welcome to Orboot messages. And that already executed the payload now, which is the REST-SBI implementation. So you get the nice banner here. And that again then runs the next payload from this offset here, which is now my, not fully yet working Linux kernel here. That's based on Samuel Holland's work. I just added some prints to it. So that's why you see these ASCII characters here. If you look at that in your hex editor, it's a bit more sensible because this here is some address that I'm printing, the r@. Anyway, that's how far I get, and then I run into the page fault here. So yeah, it's like almost ready to go this far. And yeah, feel free to ask me any questions if you have any.
Yeah, I do have a question. You are running Rust-SBI, right? Instead of OpenSBI.
Yep, correct.
How we can is that I can simply replace it with OpenSBI. Can I use that on D1 board to replace it current stuff and make it Rust SBI to boot Uboot and then boot Linux kernel or something? So can I do it right now? Okay, cool. Yeah. That's what I want. So do you have any instruction to use that? I will try to I will have a try. Yeah.
Yeah, I will just give you the link to the repository. You would need to make some changes to the code. I mean, it's really just an upstream Orboot right now. So the thing is, when you execute another payload, then it's really up to you to, do whatever is necessary there. So you might need to fiddle a bit with that. So currently it's really just executing from 0x401 whatever, lots of zeros. And then it's up to you how it continues. But really we're striving to keep everything in, one ecosystem. And I intend to, and I think that's what we're aligned on in the Orboot project, to really just keep everything within Orboot itself. So I will probably port over the work for the REST-SBI wrapper and pull that into Orboot itself so that we get just one static image, with everything, and then that can hand over to whatever you need.
A little bit like EDK2, it also put all the OpenSBI into the repo and then build itself. So you Orboot also using the Rust SBI as a kind of a library or some helper to build together. Is that correct?
Yeah, exactly. So with OpenSBI, it's like basically you build it as a library, right? But with REST, we have a bit of a different idea of modules. So I mean, in REST, you can write a program and you can pull in whatever modules you want. It's not a concept that exists in C in that sense, right? It's not like there's a registry or something. You would just pull something from the system or your local file system, whatever you have somewhere. But yeah, so for us, it's a bit simpler. And we can actually pin the dependencies using the mechanisms that we have.
Okay, cool.
Mm-hmm.
Yeah, I would definitely have a try on my D1, see if I can replace them into my D1 image. Yeah, thank you very much.
Sure, you're welcome, and thank you.
So that other target, that's the System 6, the XV6 implementation, the little operating system.
Yeah, right. So that's what Michael did. He ported XV6 to the Nezha. And so I'm just using it mostly, or I did use it as one of the first test payloads because it's a very simple system to use, right? I don't need to set up lots of stuff. It can just run from machine mode already. So, I mean, basically, I'm just putting in an extra step after exfil, which he was also using to load that. But I mean, eventually, I intend to give you a full image that you can just put on your SD card. We're just not there yet, so we need to add the magic bytes, headers, and the DRAM setup. So yeah, but that's like not too much work, just not done yet.
So maybe I can add a few words about XV6 because I assume that not many of you have seen it before. So XV6 was developed like about 10 years ago at MIT as an educational Unix-like system, which is similar to like 1975 style 6th edition PDP-11 Unix, but written in modern C without all the old cruft. And it was originally written for x86, and then they abandoned x86 a couple of years ago and ported it to RISC-V, which is now supported, but the original MIT version only runs in QEMU. And so we did some ports here. So I ported it to RISC-V 32-bit. And then I did a port here to have it as a basis for projects with my students to the NESA. And that works like rudimentary. So what's currently missing is device drivers. So we essentially support a RAM disk, a timer, and a UART right now. So I'm working on supporting like SD card and Ethernet, whatever, when I have time. And so we're trying to use this for like research projects with my master students here at NTNU in Norway, which the students really seem to like. So it's a simple system. And this means it's like a couple of thousand lines of kernel code written in C. And this might also be a pretty good basis for people who want to learn more about like bare metal programming on the NESA, on the D1 SoC, without having to dig into the Linux kernel code, which is like obviously orders of magnitude more complex. So if it's interesting to you, I can tell you a bit about what we recently did here on hardware modeling in System C with RISC-V and running XV6. Not sure if that's of interest for any of you.
Well, I would love to see it.
Yeah, absolutely.
All right, so it's just a little bit because there's not a lot to show, but maybe it's interesting. So I can try to share my screen. No, I cannot. I can try, but it doesn't allow.
I think Drew have to add you as a presenter or something like that.
Yeah, I think so.
Oh, I was muted. Yeah, let me make you a host here. How do I do that?
You can actually also allow multiple screen sharing usually, but it should work the same.
Let me see. The little widget that I normally see is gone. Let me.
Maybe you can't see it because you made Daniel a host some minutes ago, or?
I'm not sure. Yeah, like there used to be these context menus. Actually, yeah, I think maybe Daniel, because you're I think maybe you're the host now. So like, when you look in the participants menu, if you click on Michael, do you see any options there?
Hang on a second. Oh, yeah, I see a little red circle on me. So more. Oh, okay, it's a bit, hang on. It's not very suitable for smaller screens. So I need to arrange things a bit so the menu works. Okay. Make host, make co-host. Okay, now you're the host. Or maybe I will just make you the host again, Drew, and then you can make him the co-host. So I guess a co-host can screen share as well.
All right. Yes. Okay. All right. That should be good now.
Okay. So I got a message that I'm also co-host. So okay, now it seems I can share my screen. So I think you can see my browser now. So what we're trying to do is we are using RISC-V as an education and research platform for projects on the interface between the operating system and the architecture. And so we're currently working on two things. So we're working on microkernel-based operating systems and also on alternative operating systems, which are like an order of magnitude smaller than a typical Linux system. So not only XV6, which is quite primitive, but also we're working on ports of Plan 9, Inferno, some Smalltalk systems, and even the old Niklaus Word overrun system to RISC-V, and have some stuff running in simulation already, and we're working on some hardware ports. So the idea we're currently trying to get to work is, can we actually define new methods for memory management? So can we have something like fine-grained memory management on the range maybe of 16 bytes instead of a 4 kilobyte page, but also flexible memory management with like variable page sizes that can go from very small to very large, because this would support very much object-oriented systems like a Smalltalk system pretty well, or this. And the other question we're asking ourselves, can we build a microkernel, well, inspired by the L4 microkernel, as a foundation for systems like these? And for microkernels, one performance characteristic of a system is very important, which is IPC performance. And we're trying to define new approaches to accelerate microkernel IPC using a hardware software co-design approach. And for this, actually, I wanted to start with the Verilog model for the C906 or C910 that was like open source like a month ago. But this turned out to be quite complicated and slow in simulation. So a student who would start with this would need like lots of time to actually get up to speed with it. And that student who was working on it, he has a part-time job in industry, and he was working with System C. So System C is a high-level hardware description and modeling language, which is essentially a large C++ library. And it's, well, I think it's more often used in academia, but I know this student is working at Nordic Semiconductor here, so they're using it internally. And he proposed to use System C instead to model the first ideas of our hardware modifications to RISC-V. And so we were on the lookout for RISC-V System C models. And we found this one here, which is provided by a research group at the University of Bremen in Germany. Just posted a link to the chat here. So this is a RISC-V based virtual prototype supporting RV32, iMac, and also RV64 now, though it's not on the webpage so far, and a couple of peripherals. So a Clint interrupt controller, a PLIC controller, a UART, and some other stuff. And they already had some simple demos running on the Zephyr embedded OS. And we thought, like, can we get XV6 to work first? And that's what I did. So we built a new virtual platform that actually supported hardware, including an MMU and stuff that was capable of supporting booting XV6. And it's actually amazingly fast. So I have it running on a MacBook M1 here, and it's actually useful. So usually when you do modeling on that level, booting a complete kernel like takes a day or something like that. And it might still take a day when you use Linux. But for XV6, it's actually amazingly usable. And that's what it can show you. Just need to share the other window here. But that's a bit of a boring boot sequence, obviously. Which one is the correct window? Haha. Too many terminal windows open. Just a second. This one? Yes. So essentially what you see here is the System C simulation system booting up, and then you get the first kernel message. And now it takes quite some time, because when XV6 initializes its memory, it zeroes all the pages automatically. So it maps all the physical memory into the kernel virtual address space. And that takes, quite some time in simulation, because it goes through all the addresses it can reach. And then finally, after a couple more seconds, I guess, I'm not sure how much memory I configured in that current demo here. So we actually get a Unix shell, and it's really behaving and looks like a little mini Linux, mini Unix. And there's quite some good documentation. So there's a PDF document. Oh, here we go, starting a shell. There's a PDF document describing the inner workings and also the relation to RISC-V. And so we have the shell here. So whoops. We can do ls, and you see it's pretty slow because we're simulating this not quite on register transfer level, but on something pretty close to it. So it takes some time, but of course you can easily check out like adding a new approach to TLB management, to MMUs and similar stuff, which is what we're interested in. And I think that's an interesting alternative to using traditional software-based emulation. So that's what we're working at. It's not yet public on GitHub. The other XV6 ports, our Oberon port to RISC-V, and also Inferno and Plan 9 are somehow public on. So get in touch with me if you're interested. And this needs a bit of code cleanup, so I'm trying to publish that stuff next week. It would be interesting if somebody actually got Linux to work on that. That might require at least building a device tree that's appropriate for the hardware we simulate, and then getting stuff to run. But maybe we can try getting Orboot to run on that one here too. That would be great. I think that's all from my side. Two things I want to mention is, like, I could host, because there was a question, I could host the December 15th meeting, the European one, because I am in Europe. So get in touch if that's interesting.
Okay.
And I'm also, if all goes well, attending the RISC-V Summit in person. So happy to see you there if you're attending.
Oh, awesome. So you will be there.
I will be there, yes. I booked the flight and the hotel, so the only thing that could keep me from going there is Corona, yes.
Yeah, right. With this simulator you're showing, is this similar to what like Spike is, where it's doing like the RTL simulation?
Yeah, in some way. So System C can model systems on various different levels, from like a pure transactional level, which is relatively high level, down to defining like bus transactions, bus cycles, and so on. And the good thing is, depending on your model, you can mix and match stuff. So you can have a very high level simulation of one component, and you can interface it to a register transfer CPU simulation, for example, depending on where you need precision. And it's all open source, which is very convenient.
Okay, cool. So is there software you need to run System C then?
No, it's just, it runs on Unix. It's just a C++
Okay.
library that, so we made some changes to make it work on macOS on current one. It runs on Linux and it should run on WSL. So, and it's just systemc.org, I think, just downloadable. And yeah, it's a standard. There's some books on it. So it's pretty interesting because it's, especially if you work with computer science students, C++ code is a bit more approachable to them than if you force them to use Verilog.
Right, right.
And Chisel, we just had a demo of our hardware project here with our students. So one group used System Verilog, the other used Chisel. Well, Chisel felt very strange to the students, even if it looked more like a programming language. That's a bit deceiving, you know, because you're still building hardware. And so you have to think in a different way, but that's interesting.
So with System C, is it, so it's not generating like RTL, it's actually translating programming logic into hardware?
And the System C simulator first. So it's a simulator generator, similar, not quite similar, but in some way to what Verilator is doing for Verilog.
Okay.
But you can also synthesize a subset of System C. So for Xilinx FPGAs, for example, there's a tool, I forgot the name at the moment, sorry. I think it's integrated in the most recent version of the Vivado development environment that can actually synthesize a subset of System C to FPGAs. And I've been using this like 10 years ago in a course I taught about high-level synthesis. So to be honest, I need to check the current state of synthesizing that stuff. We're currently using it for like modeling new approaches to defining page tables, MMUs, maybe software-based TLB handling like in early MIPS as an alternative to see if that actually improves our security and efficiency in these operating systems we're looking at.
Very interesting.
Yeah, thank you.
Cool. Yeah, I wasn't really, I think I'd heard the name before, but I didn't really know what System C was. So that's good to understand.
Yeah, it's definitely, and I think this XV6 system also is quite useful for anyone who wants to start hacking on the NESA D1 hardware. And I think when the 15 or whatever was it, $17 boards are available widely soon, I think we get many more people looking into these systems as they become affordable. Like with Raspberry Pi, where so many people have started bare metal programming for so many things. And I guess it's a good idea to have some very simple code out there that's easy to understand, and you can refer to the RISC-V standard documents and really figure out why this bit is set somewhere. And if you start reading the Linux kernel, you first have to start understanding the device tree parser and then have to understand the dependencies there. So I guess that's a bit more difficult than just reading plain C code.
Right.
I found interesting your comment on Chisel. Yeah, I'm mostly from background of software background, totally like not hardware design or digital design. So for me, it was the opposite. I saw on Chisel way more easily to express stuff that I'm thinking about than, for example, Verilog, and with way more options like or constructs. Yeah, it's so, but the barrier between thinking of something that will run on software and hardware is the biggest transition point for digital design from someone from software background, and it's pretty fun exercise.
Exactly, especially since we teach our students sequential programming for the first year or two, and then switching your mind to thinking in parallel, that's really difficult.
Yeah,
no matter
yeah,
if it's
I think this is the
yeah.
Exactly. This is the biggest 2 points for me on digital design is thinking that everything runs in parallel and timing is everything, that you usually don't care on software because you just tell it to run and it will run eventually now or in a few microseconds or milliseconds. And in hardware, it's not like that. You're thinking cycles. So yeah, it's like, it's pretty fun. Yeah.
Exactly, and it's useful. So when students understand like stuff like state machines, they can also understand like parts of compilers which use state machines and lots of embedded software. So it's a different philosophy, I'd say, a different way of modeling systems,
Yeah.
which is interesting, especially if students see this for the first time. They start to think differently about building software and hardware.
Yeah, yeah. But once I started writing designs in Chisel, I would never go back to Verilog unless I need to do some. In Chisel, you can import stuff from Verilog, like IP, and wrap it on what they call black boxes. I usually do that, but anything I need to do, even a Blink project, I do in Chisel. It's way simpler and straightforward.
Yeah.
Although, yeah.
Yeah,
Oh, sorry.
our students here do a hardware design project every autumn semester, and we had two groups. One was building a digital synthesizer, and the other one is a simple 3D GPU on an FPGA. And so the synthesizer group was using System Verilog, whereas the 3D GPU group was using Chisel. And they got it to work. So they had like, because they were limited to BRAMs on a small Xilinx FPGA, because we couldn't actually buy the larger ones due to the semiconductor supply constraints. So they can get wireframe 3D models just simulated and animated on screen now based on their Chisel model. And that works amazingly well. So that was nice to see.
You have like Chisel test package that can run everything. You have like all tests cases in Verilator itself, kind of automatically. So it makes things way easy. And but the biggest point for me is like learning Scala and all its tooling. That's kind of pain to understand, and like SBT and the build system and all this kind of stuff. That's kind of complex.
Yeah, it's just a completely different approach, but it's interesting to see that it's possible.
Yeah, but I love it either way. Like I'm all the time in Chisel channel, and if your students are interested too, in Chisel 3 we have like a Gitter channel, and the developers from Chisel are always there, and they are very helpful. And if they are interested, please drop in. It's
I'll let our students know. Yeah, they'll definitely be. Yeah, thank you.
I'm gonna grab the link to that.
And we're actually using RISC-V in education here. So in our computer architecture course, which is taught by a colleague, the students actually model a simple 5-stage RISC-V pipeline in Chisel. And they get it to work in simulation. So they know quite a bit about RISC-V already, which is good. Oh, thanks.
I'm in the process of rewriting my single cycle core into a 5-stage pipeline, and I'm having like all hassle and problems and trying to understand how it all works.
Exactly. So I actually wrote a single cycle RISC-V in Verilog on a rainy weekend here, and I'm still amazed it works because I'm not a hardware designer. I'm an operating systems guy. But it's really important to get the hardware guys and the OS guys talk together to see what's possible instead of just defining an interface and the other side has to live with it.
Yeah, like me, like writing a core is like a big milestone. I even got like UART running, some GCC C programs running on that, and it's amazing to know that's running on something you wrote yourself.
Yeah, and it's so motivating for students to see that they can actually build a system they can understand. Which is one of my objectives here, that, so many computer science students only see high-level abstractions, and I want my students to really learn what's going on from the metal to whatever WebAssembly they run in their browser, and to see like where's performance lost, where can we gain performance and energy efficiency. So we're doing quite some embedded stuff, and that's interesting, I think.
Yeah, it's very interesting. Yeah.
Is there a like a graphical visualizer that you use when the students are developing like the RISC-V core to like see how things are working?
I'm not sure. I'd have to ask my colleague who's teaching the course actually, or the students, because I'm teaching compilers and operating systems here. The colleague next door, who has gone already, is teaching the architecture course, but I think most of our students are actually pretty much hardcore Unix hackers using makefiles and UI, so I think they would be confused about visualizations.
Okay.
But they learn, the first thing they're going to learn is how to write test cases, so that's already pretty helpful. So really writing a test bench first and then starting to think about your design.
Nice.
Yeah, I did something pretty similar in my core. I started writing the tests and then writing the module itself. Yeah. It's like test-driven development from software word.
Yeah, it's really nice to see that. So most times when I looked into more low-level development, people were always like, let's try it on the real hardware and see if it works or something. But yeah, do you also intend to introduce them to Rust? So I think it's a bit easier to approach, especially in terms of test-drivenness.
I think from my point of view, the biggest problem with Rust is having the students understand what's going on behind the scenes. So especially all the static analysis for the borrow checker. Like I knew when I read about it the first time, it took me a weekend to wrap my head around it. And I taught a course on static analysis. So it has a steeper learning curve than C, but in the end, it's rewarding. So we discussed this for the compilers course. So currently in my compilers course, the students are writing a small compiler for like a procedural language like Pascal down to currently x86. So we're also thinking of switching this to RISC-V in the backend. And so they're currently writing it traditionally YAC, LEX, and C on Unix. And so C is the biggest problem here because C is not made for writing compilers because you need data structures like trees and lists and hash maps. And all of this you need to write yourself. So students were struggling mostly with pointers in C instead of with writing the compiler. And Rust might be useful here. So I have a project right now with a student who's very good at Go. So he's re-implementing all our compiler stuff in Go, and he's pretty much likes it. So maybe there's a difference, like Rust for system level stuff, Go for application stuff that's developing a bit, but it's hard to say what it turns out to be.
Mm-hmm. Yeah, that's exactly actually our mindset as well. So in the Harvey OS project, we're using the Uroot userland also.
Yeah.
Or we intend to use it again once we get it up and running. And I mean, so we just recently rebased.
Yeah, and the Inferno OS has already demonstrated that this works well. So Go is actually the successor of the Limbo language in Inferno. So it's essentially the same team working at, Google, obviously, and previously Bell Labs. And so some of the old Unix guys and even one of the former PhD students of Niklaus Wirth at ETH Zurich who worked on Oberon. And so that's where you see all the module specifications for Go coming from. And so the interesting thing is really, that it worked already in Inferno, also on systems with very small memory. So we built a RISC-V just-in-time compiler for the Inferno bytecode VM called this. That works pretty well. And I think this approach could work as well for other operating systems on RISC-V, compiling from Go, and then you can still use Rust because you need a memory safe, non-garbage collected language. That's at least what I wanted to have if I write kernel code. Yes.
Yeah, sounds good. Thank you.
Yeah, welcome.
Hey, Daniel, I code in Go. Should I take a look at Rust?
Well, definitely for the bare metal stuff. I mean, what Michael just said, right? But of course, also feel free to look into Uroot, for example. And we have a bunch of stuff actually written in Go right now. That is what we use in Harvey, for example. We have a very, very nice tool that is called Cendre with the British spelling. So CENTRE. That's in the Harvey OS repositories. And that's, a combination of DHCP, TFTP, and whatnot. So you don't need to set up all this weird stuff yourself. Maybe that's something interesting also for others here.
What is Harvey? Oh.
So Harvey is a Plan 9 operating system that was at some point based on a Nix kernel. And we just recently switched to one of the more recent Plan 9 kernels. If you go to harvey-os.org, I will put the link here in the chat as well. You can go check it out. And so we just got to the point, I think it was actually just merged yesterday, where you could build it again from a some foreign Unix system or Linux or something. We have a Docker file now, which you should be able to build it with. No warranty though, so it's really just very, very fresh and recent work. And so besides Harvey itself, the kernel, there is a repository called Go. So github.com/harvey-os/go. And that's where we have Sender and all the other nice and neat tools.
So so Plan 9 and Go, was that the same people were behind those? Is that right? They're related?
Yeah, sort of.
Okay.
It all goes back to Bell Labs at some point.
Okay.
Definitely. So did you see that actually the Jeff Coiler published his Plan 9 kernel sources for RISC-V recently?
No, I haven't seen that yet, but that's definitely interesting to look into.
Yes, I have it running in emulation here, so I'll send you a link separately because I have to look it up. It's somehow just available on the Plan 9 file system service, and it's not linked from the web page, but it's there. You can download it. I'll have to figure out the link. I have it here.
Perfect, thank you.
So one question that interests me. So what's the difference between 9front and Harvey? Or is this too religious?
Maybe also political. I'm not exactly sure. Well, to be honest, I'm rather new to the project myself. I just, I don't know, started hacking a bit on it like 2 years ago. And from what I can tell by now, it's, well, mostly a few different people, but we also have a bit of collaboration going on now because the 9front people, let's face it, they did some really, really nice work,
Yes.
Especially getting things working, right? So like running on the Raspberry Pi, for example, that's something very nice they did. And they also cleaned up a bunch of stuff.
The work of Richard Miller actually in England, yes. But yes, they really made it run really well, yes. Yeah, cool. And so for our parts of Plan 9 and Inferno, we used Richard Miller's RISC-V Plan 9 compilers. They had some bugs. I think they're fixed by now because my students gave some feedback. And so this seems to work really well. So I'll send you some stuff over Telegram, I guess, as soon as I figured out where I found it. And if anyone else, feel free to get in touch, obviously. And I think it's good to have alternative operating systems to run on RISC-V and not just Linux. So I have a Hi5 Unmatched here. It's running Haiku at the moment, which is the open source BOS clone. So there was one developer porting Haiku to RISC-V in over 3 months. And he had it running on QEMU after 3 months, and then another month to run it on the Unmatched board. And it's running really well. And especially on relatively slow hardware like the D1, it might be quite a nice system to use because it uses like far fewer resources than a typical modern Linux system. Yeah,
I think OpenBSD should also have a port available on RISC-V by now. Yes. And I'm not sure where exactly it runs, but I guess it should be also not too hard to port to the Nezha.
It runs on the Unmatched, as far as I know. There was a master thesis record from last year, and that's what this is based on, I think. I need to look it up. I have so much stuff on my disk here, yes. So yeah, maybe, I don't know, is there something like a BOF session, Birds of a Feather session planned for the RISC-V Summit? So maybe it's a good idea to have something like a BOF for alternative operating systems on RISC-V?
At the summit? Yeah, I do think that's a good idea. I don't know if it's possible to add something in this point.
Can maybe ask Megan if she organize some stuff. Yes.
I think it's a good idea. Yeah.
Yeah, definitely. Great.
Cool. It was great to have some people share stuff today. So thank you. It's exciting when other people present as well.
Yeah, so I also
thank you for having us.
Yeah, thanks. I also gave a presentation if you're interested in XV6 on the RISC-V Academia interest group meeting. I need to look up the URL, sorry. So maybe I can just post it next time around. So the video is out there somewhere.
I think, did it get published under RISC-V YouTube? 'Cause I feel like I saw a link somewhere
Yeah,
for it.
it should be there. I think Megan put it somewhere.
Let me see, because I feel like I saw it come up. It was part of, was it part of a meetup or, oh,
For the academia group like 2 weeks ago, yes.
Okay.
3 weeks ago.
yeah, I just see Duisburg meetup. So yeah, I'm not sure. Yeah, I saw it as well somewhere, but now I can't remember. But I'm sure. Well, you're on Twitter, right? So you can tweet it out when you find it.
Yes, exactly.
Okay. Cool. All right. Yeah, I think I have to get going soon, but yeah, thanks everyone for joining this week, and yeah, I guess.
Okay. Can
yeah.
you see a blue screen now?
Yes.
There's some text on it. Yes.
Okay, found the video,
Okay.
so I linked it.
So
Okay.
yeah, thanks for
Cool. Oh, so you got the link now?
Sorry, it was auto playing here.
Yeah, no problem.
So that's the video link. So that's a bit about what the challenges are porting the x86 operating system.
Oh, this MP4. Okay, gotcha.
It's an
Okay.
MP4 video, yes.
Cool. All right. Very cool.
So
Awesome.
looking forward to seeing some of you in San Francisco in like 2 weeks, about 2 weeks-ish. Yes, a bit less, yeah.
Yeah, definitely. Yeah, it should be fun. Great. All right. Well, great to see everyone today. Yeah, and I guess I won't make the next couple of ones. So I'll send you the information about hosting. And yeah, otherwise I'll be back for hosting in January.
Yeah, awesome. It's been
right.
great. Thank you very much for everyone.
All right. Thank you.
Thank you.
Thank you.
Bye.
See you.
Thank you
Bye-bye.
too. Take care.
Bye.
Bye.